It was a sunny morning. I was sitting in a bright conference room at a promising startup's offices. Opened my laptop, feeling happy as their new cloud infra consultant. The CEO looks at me and says, "Show us how these containers will change everything." I start typing, talking through the process as I build the first container. See how easy that was? One command and it's ready to ship. Let me just tag and push. 30 seconds later, it happens. The CEO phone buzzes, then the CTO's, then every developer in the room starts pulling their phone out. What's going on with AWS? His face turned pale. My stomach drops. I grab my phone and see two critical alerts from AWS flooding in. Your master key has been compromised. Immediate action required. In that moment, I realized what I've done. The script inside my demo container, the one I just pushed to a public repo, contained their AWS master key in plain text. The room goes silent. All eyes turn to me. I accidentally pushed your AWS key to a public repo. The CTO stands up. We need to rotate all keys immediately, lock down the entire platform. They all go into emergency mode, panicking and blocking all access. The startup I was supposed to help is now completely paralyzed. 2 days later, I'm back in my flat, staring at a termination email, fired, embarrassed, and carrying a valuable lesson I'll never forget. This was 9 years ago. 4 years later, I relied on a random set of solutions, local Git hooks, leak scanning tools. I still have a constant fear every time I push something public. But last month, I found something new. If I had it 9 years ago, things were different. Let me show you what I've got. Let me pull my own container and run locally. Since I have the Docker file, I can just read the instructions to guide me, but this is available on any public container you pull. It looks like myscript.sh lives on the root path, so let's read it, and what do you know? Clear text AWS key pair. But give it up, they're gone by the time you're watching this. Running the script directly successfully retrieves the bucket on my account. And yeah, I did create the script, but I can't tell you how often I get to see these in public Git repos, public containers, and everywhere else. If you don't believe me, check this out. Go to GitHub and search AWS Access Key ID. Is 967,000 results enough? You can also hack this by running it with a typo to catch those that were missed by other scanners. Anyway, back to our story. The first tool I'm going to run to show how easy it is to pick these leaks by anyone is Git leaks. I'll use Docker here too, just as a wrapper for the tool to get the latest more easily and mount my current workspace to it. It scans Git files by default, but we'll just add --no git to make it scan everything. Both leaks are easily printed out. New shell fans can open the output JSON report and scan the columns, take out the secret, and there we have it. What if we could compile the script before even building anything, turning it into a binary code no one, well, 99% of users can't read, surely no scanner can detect? Does it mean you can now push your secrets everywhere freely? Absolutely not. Does it mean lives will be saved if this is constantly used? Absolutely yes. Let me take a few seconds of your time for a quick message. Using AI to generate code, even just for a little bit, I guess we all are. That's awesome, but did you know that AI generated code can introduce serious security vulnerabilities even without you realizing it? This video sponsor, Snyk, the leader in developer-first security, are giving you something you absolutely don't want to miss. On Thursday, April 3rd, they're hosting a virtual workshop called Life Hack Exploiting AI-Generated Code. And trust me, your head is going to explode. It's a hands-on session where you learn how to identify and fix vulnerabilities that sneak, see what I did there, into code generated by tools like Copilot and ChatGPT. We're talking SQL injection, cross-site scripting, directory traversal, the real threats that can compromise your applications. What I love about Snyk's approach is that it's practical. You won't just hear about the risks, you'll see real exploits in action and learn the exact techniques to protect your code. Mark your calendar, Thursday, April 3rd, 11 a.m. to 12:30 p.m. Eastern Time. Register now using the link in the description to secure your spot. Because when it comes to AI-generated code, what you don't know can hurt you. Now, back to the video. Meet Bunster, a Golang project that serves as a shell compiler, turning bash scripts into binary executables. The nerd in me is excited. Bunster isn't just compiling, it's built to work with modules so that scripts can be consumed as libraries, support pipes, CLI arguments, and even .env files. Check out the video above if you're curious about .env files and how I manage them with .envx. To install Bunster, grab the installation script and run it locally. In Linux, you're going to find it under local/bin, and on macOS, it's strangely deployed under home/bin, so I'll be running it directly as it's not in my path and I'm lazy. Bunster comes with a few commands. We're going to use build, but a few seconds before doing that, let's talk about its generate command, which is more interesting to me. If we take a simple hello world bash script and then Bunster generate it into a module, you'll see a full-blown Go module built around it with shell extensions, argument support, and an actual program that takes the commands in the script and translates them into working Golang code ready to be compiled. This isn't something to take lightly, and the author has done some serious work around it. Okay, time to see the magic. Bunster build with the source script and the -o for a binary output name. Let's call it a generic script. 1 second later and my binary is baked. I can even run it and list my AWS buckets again, this time from a binary. To those of you thinking, yeah, you could have just wrote Go code and compiled that. You're not wrong, but then again, the simplicity of literally writing one bash line and building that into a binary is quite impressive. Don't do this at home, kids, but if I try to read the binary, there's nothing to see there. I was even curious enough to pop it into NeoVim and see whether some of the code, like my keys maybe, have stayed in clear text. If anyone does try to read it, doesn't seem this way. I do, however, want to stress one important drawback. Look at this file list and tell me if you see anything out of the ordinary about both file sizes. Yeah, the compiled binary is quite larger, 35,000 times larger to be exact. A binary comes with its own runtime, static linking, and other optimizations in preparation to run it on the machine level rather than having a runtime and an interpreter around it. In a way, kind of like wrapping an operating system around an app, which is, if you think about it, kind of what compilers do. Now, in our theme of building a container around our script, we can copy the binary instead of a readable script, making things tidier, more professional looking, and honestly, a bit more secure. We'll call our new container safe container and run that. But here's a problem which is crucial when compiling anything. If you're using a different system to build and run the script, for example, me using macOS with an Apple chip to compile something running on Linux later, and probably on an AMD 64 chip, it's important to use the correct Go environment to cross-compile our script. We'll set Go OS to Linux and Go architecture to AMD 64, and then rerun Bunster. Now, while my local machine can't handle the new compiled binary, the safe container running Linux happily executes my AWS bucket lister. But will Git leaks catch the leaked keys? Let's see. It's clean, no leaks found, with my exported secrets safely tucked in there inside the container. Let me stress this again, I'm not suggesting leaking things as a practice, but I am suggesting compiling scripts when it makes sense to make things slightly more secure. Another level you can take things now with the compiled binary is running a distroless container from scratch to make the container not only incredibly smaller, but also taking away any form of shell for anyone to use or attach to. Don't get me wrong here. I don't advocate that you start leaking everything just because you can now compile binaries. Not only it's bad practice, binaries can be reverse engineered, and leaking as a method is setting yourself up for failure. That said, as you've seen, it's great to be able to release more secure applications and lighter containers, but these don't mean much if you don't master Docker's solid basics. Check this video next to build this program into your brain.
I know Kung Fu.
Show me.
Thank you for watching, and I'll see you on the next one.